All right, so the outer side of a vertical circle has to do with cases where a car is going up a hill, which is considered to be a part of a circle. All right? So this is when we have a car, we have an object doing the outer side of a vertical circle. What is going on here, right? So we do have the force due to gravity. We do have the normal force, which goes up, apparently. The radial axis is this. This is the radial axis. This is the vertical axis, let's call it x. And what do we see now? So we see that we want the centripetal acceleration to be always towards the center of the circle. That means that the force due to gravity plays that role. And the normal force reacts. So what do we have here? So if we consider this to be positive, I should consider this to be positive and this to be negative. Or the other way. So we do have the force due to gravity, we have the normal force, and we have no other forces. We may have the engine force, friction, but we don't care about it right now. We consider that if those forces exist, we don't care, they will cancel each other. So the sum of forces on this axis should be zero, while the sum of forces on the radial axis should create a centripetal force and acceleration. So this is the right. Okay, so what do we have now? We have that the force due to gravity minus the normal force should create the centripetal force. So in this case, if I solve for the normal force, so yes, I want to solve for the normal force. Why? Force due to gravity is the same, doesn't change. So let's see what is going on with the normal force. If I solve for the normal force, it will be the force due to gravity minus mv squared over r. So what do I see here? The higher is the speed that the car has, the highest, the part of the force due to gravity that will be used as centripetal force. That means that the normal force will be less and less. And there will be a speed high enough where the normal force will not be needed. It will be zero. I'm sure that I have felt it. You have gone up a hill, and if you do it high enough, you see that by the time you turn, you feel as if there's no force between you, no pressure between you and the seat. It's like you enter a state of weightlessness. Remember weightlessness? Weightlessness doesn't mean no weight. Weight, the force due to gravity, always exists. But state of weightlessness means that the apparent weight, the pressure, the normal force becomes zero. So if the speed is strong enough, the normal force can become zero, and then you enter a state of weightlessness. This is what we saw with the airplanes, the zero-G airplanes, that at the top of the curve, at this area, the G, the force due to gravity, the acceleration due to gravity was used as a centripetal acceleration, and the force due to gravity was fully used as centripetal force. Therefore, there was no need for normal force. And that was the state of weightlessness. I hope I explained it well.